So we continue with exercise 4.4, fourth sum, solve. To start with, let us do the first one. I am sure once I do the first one, the second one will be a easier one for you and you can do it on your own. So this is the question. This is the left hand side of the equation equal to, the right hand side is 4x minus 5 upon 2x plus 3. So when we basically think about this sum, we have to see, you have to solve. That means you have to get the value of x. So whenever it is solved, you have to get the value of x. To get the value of x here, you need to eliminate few of the terms. That is a basic thing. So when I look at this right hand side, that is going to be the helper for me. So here I have is, just I am doing the things in my working column, 4x minus 5. Kindly pay attention to what is the working part here. 4x minus 5. If I multiply by 5, I will get 20x for sure. But I will not be getting this 9 which is going to help me. So that is the reason I have to think to multiply this by 4x, which would be giving me 16x square minus 20x. Right? So that is the reason I want to multiply the second ratio by 4x. But before I multiply by 4x, I have to conclude that x is not equal to 0. So before we conclude that, we have to check what happens if x is equal to 0. So if x is equal to 0, the LHS part becomes, put x as 0, 16x square minus 20x plus 9 upon 8x square plus 12x plus 21. If I put x as 0, the value is 9 upon 21. Same way, if I put 0 to the right hand side of the equal to, 4x minus 5 upon 2x plus 3. This becomes, yes, very correct. In place of x, 0, so it becomes 5 upon 3. So from this, what can I say is 9 upon 21, because your equal ratio here, is the relation equal here? Yes, is the relation equal here? When I look properly, I can see it is not equal. Right? From 21 I can obtain 3, but from 9 I cannot obtain minus 5. So therefore, this condition is a contradiction. So this is a contradiction because here the ratios are equal and here we are finding that the values are not equal. So this tells us that x is not equal to 0. So when x is equal to 0, it is giving a contradiction. So therefore, I say x is not equal to 0. If x is not equal to 0, then my sum goes in the different manner. That is, now I can take the liberty of multiplying the second ratio. I can take the multiplying the second ratio by 4x, both in the numerator and denominator. So what do I obtain? The first ratio remains as it is. There is no change in this. And the second ratio is where I am multiplying 4x both in the numerator as well as in the denominator. No partiality at all. and this is equal to, yes, k constant. Okay. Now let us solve further. We get is the left hand side of the equal to remains as it is, no change here. But the term here it becomes 16x squared minus 20x upon 8x squared plus 12x, that is equal to k. Right? Now by theorem on equal ratio, here comes the actual thing which will help us to solve it further. By theorem on equal ratio, what do we have is the whole term which is there in the numerator minus the whole term here. So what do we obtain? Yes, why are we minus? Then only you can find the terms gets cancelled. So same way here also, 8x squared plus 12x plus 21 minus 8x squared plus 12x. Don't forget the k. As you go further, you can see terms are getting cancelled here now. Correct? The terms which are getting cancelled, before that, open the bracket. What you obtain is 16x squared minus 20x minus 9 minus 16 plus 20x upon 8x squared plus 12x plus 21 minus 8x squared minus 12x equals to k. Now in this process, can you see same term with opposite signs? Same term with opposite signs. So they cancel each other. What are we left with is 9 upon 21, that is equal to k. So therefore what can I say is, therefore I can say, I know k is also equal to 4x minus 5 upon 2x plus 3. Yes, now you can see the linear equation. So what we do now here is, see, this we can cancel further to give us 3 3s are 3 7s are, right? Cross multiply will give us 3 bracket 2x plus 3 equals 7 bracket 4x minus 5. What do we obtain? 6x plus 9 equal to 28x minus 35. So when you solve it further, what we get is 28x minus 6x equal to 28x minus 6x is equal to, take the term other side, 35 plus 9, giving you, here when you subtract you get 22x, here when you add you get 44. So what is the value of x? Therefore value of x is 2. So once you get the value of x as 2, you can see that you have solved the equation. So therefore answer for the first one is x equal to 2. Now I hope the sum is quite clear. We go for the second one. I'll just give you the hint for the second one, but you are doing on your own, right? So the hint for the second one is 5y plus 5y square plus 40y minus 12 upon 5y plus 10y minus 4 equals so here the hint is for you, same way, what is the term we will multiply in the second ratio, right? Here we have y plus 8. If I multiply by 40, I won't get a 12, right? So I have to multiply by 5y. So 5y if I multiply, that is a hint for you. Children, keep in mind, and that gives you 5y square plus 40y. Same way, in the denominator, you multiply by 5y, you will get the same 5y plus 10y square. Followed? So that is how you are going to solve this sum, and I hope you will surely get the answer correct. Then now we go to the next, that is the continued proportion. Now in continued proportion, we have, according to the syllabus, what you have is 3 numbers in continued proportion, and that is what is totally there. Okay, so let us start with the continued proportion. You have basically 3 numbers in continued proportion. Sums related to this are there in your exercise 4.5 as well as in exercise problem set further. So let us start. When I say the word continued proportion, before that I just want to basically know from you, do you know what is proportion? Inverse proportion. Yes, there you had studied it as variation, correct? Now, what is proportion? When two ratios are equal, like A upon B is equal to C upon D. When two ratios are equal, then the 4 numbers here are in proportion. So, how many numbers here? 4 numbers are in proportion. Same way, when I say continued proportion, so you can make out it is a type of proportion. Okay. So, what is continued proportion? So, to understand that, there is something which is continuous, right? So, A upon B is equal to C upon D. That is how it is in proportion. But in continuous, it continues further. B upon C. Further, if I have, this is 3 numbers. If I have 4 numbers, then it goes like this, C upon D. If I have 5 numbers, it goes further, D upon E. It goes like this. Is that very clear? So here, according to your syllabus, you are learning continued proportion of 3 numbers. Now tell me, what is the relation you obtain from here? Cross multiply. You have B square is equal to AC. Yes or no? Yes, all of you agree to this? Okay. If you agree to this, I'll just put some more thing further to say here B is the mean proportional. Right? So what is A and C? So if B is a mean proportional, A and C are, we can say B is the geometric proportion, that is geometric mean. There is one more word which will be frequently used in the sums. It is geometric mean. So B is the geometric mean of A and C. Is that very clear? So looking at this concept which is given on page number 74, I also would like to discuss with you the K method. Okay, the K method, what is going to be used when you use the numbers in proportion. So I continue here itself. This is equal to k, a constant, right? So what is a equal to? A is equal to bk. bk. What is b equal to? Yes, b is equal to ck. Agreed or not? This ck I will substitute in place of b. So this becomes ck into k, that is ck square. So keep in mind, b is ck but a is ck square. This is how we are going to use them in the sums, okay, by using k method. So let us start with 4.5 with this much knowledge. There are so many solved examples here, children. You are going to solve them and try to learn from there how to solve the sums there. Now let us start with 4.5, and I would rather go to problem set first and do sum number 5, because I first want to do with you some where we are directly applying the knowledge of continued proportion. Look at sum number 5 of problem set. Fifth one. Question says that A, B, C are in continued proportion. I would write continued proportion as CP. Okay. Further, what they have said, A is 3, C is 27, find B. First and foremost, we make use of what is given to us. A, B, C are in continued proportion. Therefore, I can write this as A upon B equals to BC. B upon C. Therefore, B square is equal to AC. B square equal to AC. Yes, so B square is equal to 81. So B equals to square root of 81, giving us B equals to 9. Is this very clear? So that is how the fifth sum is done. Now we go to the fourth one. Check whether the following numbers are in continued proportion. So I'll do, there are 4 sums, I'll do 2, you will do the remaining 2. Fourth, I'll do the first and the third. Odd for me, even for you. 2, 4, 8. They're asking us whether they are in continued proportion or not. How do we show that? We first take the number and we try to see that which is the mean proportional here if these numbers are in continued proportion. 4, right? So we check what is 4 square. 4 square is 16, right? And then we take the product of the other 2 terms. What is 2 8s? That is also 16. Therefore, what do we conclude? 4 square is 2 into 8. Therefore, B square is equal to AC. Therefore, what can I say? 2, 4, 8 are in continued proportion. Is this very clear? Now, going further to the next one. Yes, as I said, I'll do the odd, or I'll go for the second one. Okay. The second one, because as you see, the third one again is in continued proportion. So I take the second one. 1, 2, 3. So what is here? Which is the middle term? Yes, 2. So let us find 2 square. What is 2 square? 4. What are the remaining 2 terms? 1 into 3. What is 1 3s? So what is it? 3. Correct? Therefore, what can we find here? 2 square is not equal to 1 into 3. Since it is not equal, we can say 1, 2, 3 are not in continued proportion. So now I think at least the basic idea is very much understood, children, that you have to look for this b square ac, right? So that is what is the need here for this sums to be done. There are 2 more sums and I don't think you need my help. You can try doing on your own. Okay.